All right, we're going to take a look at solving some right angle triangle questions. So we're going to use Pythagorean Theorem. I'm going to try and show you a way that you can do it perhaps with kind of skipping the algebra part that sometimes people find a little challenging. So here we have an example of a right angle triangle. So if I go back a page here, Pythagorean Theorem says that if you have a right angle triangle, it has to be a right angle triangle, that if you take the area, so if this is the right angle, this would be the hypotenuse, it would be the largest side here, which means that if you attach a square to it, so if you square this side, that square would have to be the biggest. And when you look at Pythagorean Theorem, it states that the area of the two smaller squares that you would attach, so if we look at maybe labeling this side A, this side B, and this side C, which tends to be the most common labeling that people use. This square would have an area of A squared, this square would have an area of B squared, and this side would have an area of C squared. So what Pythagorean Theorem states is that if you take the area of this square, which looks to be a 3 by 3, so the area of this square is 9 units squared, so if it was centimeters, it'd be 9 centimeters squared, or meters, 9 meters squared. This square has an area of, it's a side length 4, so it must have an area of 16, 4 times 4 if you can count them. So what Pythagorean Theorem states is that if you take the area of these two squares and you add them together, you will get the area of the biggest square. And we can check that. So that's 1, 2, 3, 4, 5 is our side length. 5 squared is 25. And you can confirm that 9 plus 16 is 25. So that's what Pythagorean Theorem states. Now, more often than not, we don't end up solving for the area of one of the squares as our final answer. Our final answer ends up being a side length. But in the process, we do have to have these areas of these squares. And then there's another example of a right triangle here with the area of some different ones. So I'm going to try and look at two examples. So in this case, it is just the first triangle we looked at. But what we're going to do is solve for the longest side, which is the hypotenuse. So the way that I often think students maybe should start out by doing this, and I do have some square tools and stuff here that I could do a good job of drawing it, but I'm going to try and just do it as if I was using a pencil and paper. What students can do is just sketch your squares. So if you have a sketch of your triangle on your page, what you can do is just sketch the squares as if you were attaching them. So once again, these are not going to be perfect squares because I'm just sketching them on here. But what Pythagorean Theorem says is that the area of this square added to the area of this square has to be the area of this square. And that one wasn't so great, but you get the idea. There. So, well, if we know the two little squares add up to be the big square, that's all we have to remember. So how do I find the area of a square that has a side length of 3? Well, we would just do 3 times 3, which would get us 9. So this square would have an area of 9. It has a side length of 3, an area of 9. This square would have an area of 16, which means that you would then say this square area has to be 9 plus 16, which is 25. Then once you get the area of the square here that you're looking to find the side length of, you can think, okay, if I had a square that had an area of 25, what would one of the side lengths be? Now, a lot of these should be mental math if they're nice, perfect squares that are, not too big. So hopefully you know that 5 times 5 is 25. If not, what you would be looking to do is use a calculator to find the square root of that number. So you would have to use the square root button. In this case, the area of that square is 25. So our answer is 5. So x would have to be 5 in this case, which would be our hypotenuse. Now, to match what we just did there up with the algebra, so you would start with an equation that is generally given to you. So a squared plus b squared equals c squared. You can write this the other way around. You can say c squared equals a squared plus b squared. It doesn't matter. So what you end up doing is you square whatever the two smaller side lengths are. And those side lengths are given to you at the start of the question. So this is, once again, we're solving for the biggest side, the hypotenuse, so we will be given the two smaller lengths. So if we want to think this is A and this is B, it doesn't matter which one is A and B. It does matter which one is C. So what we're doing here is we got 3 and 4, and we have to remember that, oh yeah, we're squaring them. And it's literally just asking us, if you had a square that had a side length 3, what would the area be? So 3 times 3 is 9. You can put that in your calculator as 3 times 3, or you can use an exponent 2 button or a squared button if you have it. So this is the one that's on my calculator, so I could write 3 squared, and it will give me my 9. So 4 squared is 16, and that has to be equal to our c squared value. And it's the same process of what we did over here when we drew the squares on it. We're just doing it without, drawing it out. 9 and 16 is 25, so 25 has to be c squared. And your final step is you want your answer to be what is c all by itself. So you have to undo the squaring part here. So the inverse operation is square root. So you do it to both sides of the equation to make sure that you keep that balance. So the square root of c squared is just c, and the square root of 25 is 5. And then if they have units involved, you would have to put in whatever the unit is. When you solve for the side length, it won't be a square unit, it will just be a one-dimensional unit. So it may be like just centimeters, or just meters, or inches. It will not be inches squared or centimeters squared because it is a side length, it is not an area. We'll do one more, and this time what we'll do is we will solve for one of the sides that isn't the biggest one. So I believe in this example, this side length is going to be 10, but I should be able to move this out of the way. So once again, we're just labeling, this is the side that I'm going to want to find. It actually looks to be the shortest side in this example. So we can sketch the squares on the edges of the triangle. We can sketch those squares on the side lengths. So if I move this, I already have it drawn out with actual grid squares. But once again, if you were to do it with just a pencil, you could jot on a rough picture of a square and say, okay, I know that that side length is 8. I know that this side length is 10. I'll move those out of the way. Now this square here, if the side length is 10, then the area must be 100 units squared. If the side length is 8, then the area must be 64, because I'm doing 8 times 8, 8 rows of 8. And once again, I had those pictures originally there to prove to you that it's 64. If you count them, there's 64 squares. If you count these ones here, there's 100 squares, and you can see how poor my drawings are. And then this is the one that we're trying to find in terms of the side length here. But in order to do that, we need to know what the area of that square would be that you would attach on the outside there. Well, we remember that Pythagorean theorem says that the two small square areas, so this area and this area, have to add up to be this one. So we need to find out what this area is first. So if these two add up to be this one, we're asking ourselves, what number do I add to 64 to get me 100? So we are trying to find the difference between 100 and 64. So that turns into a subtraction question. What does 100 take away 64? Well, that's going to be 36. So the area of this square here is 36. Your final answer is going to be what is the side length of a square that has an area of 36. So once again, that's the square root. But if you were to look at a picture of it, you could count. Okay, there's 36 squares, 6 rows of 6. So that means that one side length of 6 is my answer. Once again, if you don't know that, you can use the square root button on your calculator. So in this example here, my side length y is going to be 6, and let's pretend that they're all centimeters. So this would be 100 centimeters squared for my area, 64, 36. And then when I get my final answer, it's just centimeters. It's a one-dimensional length. How would that look if we were going to do it algebraically? So a lot of students want to like write it out, memorize, okay, I know I'm going to do subtraction, so I got to write it out a different way. I normally just write the exact same equation every time. A squared plus b squared equals c squared. I have less things to remember if I'm doing it that way. I then fill in the values that I know. But if I'm going to label these and say, well, the longest side, it's opposite the right angle, that's my hypotenuse, that has to be c. These are interchangeable. I generally make the second biggest side b, and then this one, although it was labeled y, I can relabel it a. So I'm solving for a here. What I can do, though, is I don't know what a is. I'll just write it down again as a squared. I do know what b is, and I do know what c is. So I'm going to substitute those values in. So in this case, b is just 8. That was given to us at the start. And c is 10. That was also given to us at the start. So if I simplify everything in this equation that I can't simplify a squared. That's got to stay there. I don't know what that is. I'm just going to write a squared again. But I do know that 8 squared is 64, so I add 64, and then that has to equal 10 squared, which is 100. So I get to this point, and it says some number squared plus 64 equals 100. So at this point, I can solve this equation by saying, well, I want just the term with the unknown in it all by itself on this side of the equal sign. So I'm going to subtract 64 from both sides. I apologize, that looks like a 9. If I subtract that from both sides, on the left side, I'm just left with a squared, because 64, take away 64 is 0, and over here I'm left with 36. So now, in our picture, the way we did it, we're at the point where we know that the area of this square is 36. And our final step is, once again, to find the side length. Algebraically, that means we're taking the square root. So, once again, if I have an area of 36, I have a square that has an area of 36, what's the side length? That's what the square root is asking you. So my answer here is going to be 6. The square root of a squared is just a. So I know that my answer is a equals 6, and we said it was in centimeters. If we're asking a question where we just want an answer and it doesn't specifically say that you have to do it this way, this is a nice way to kind of fall back on and avoid the algebra. This is the way that I would think people should remember Pythagorean theorem in their head. It's easier to remember kind of this picture. This is where it comes from. This is what the actual relationship is. These are just the symbols that are telling you what's going on here.